How many times have you started printing and unfortunately the first layer failed? One of the reasons it may have failed is maybe the problem with the probing of the bed. There are a lot of solutions on the market, and today we will be looking at the Voron TAP, the newest release from the Voron Design team. We'll start in a couple of seconds. Voron printers or Voron Design printers are, as a matter of fact, non-existing printers. No, that doesn't mean that they do not exist, but you cannot buy them. The Voron Design groups creates designs that then people can print, buy material and build themselves. While each of the printers is based on the specification that was released by Voron Design team, each of the printers also is unique. Maybe you bought linear rails from one vendor, or you changed the color of the printer, or you did some other minor upgrade or tweak. So each of the printer is individual. The one thing that Voron printers had and people didn't like is the proximity sensors. And these are these Hall effect sensors. What it means? It means that you have to have specific type of the build surface. And when the tool head is lowered, it will detect changes in the magnetic field, and because of that it will know that it is approaching the build plate. It never touches the build plate. There is always some kind of distance, of course, if you did everything correctly. If not, it would just smash in the build plate. The other thing that the Voron 2.4 printer had to have was the Z-stop. This is a switch that was mounted on the back side, and the nozzle would touch it so that it would know where actually the nozzle is located in the space. You have Hall effect, which tells you I'm approximately here, and then you have nozzle touching the switch. For people that wanted something better, there was a Kliky. Kliky was another open source project, not by the main Voron Design team, but by the enthusiasts that build a switch that the printer would take when it needs it, then dock it when it doesn't need. And it would then use this switch to touch the build surface. They were saying that this is more accurate and better for printer. But in December of 2022, Voron Design team has released Voron TAP. What Voron TAP does, it completely removes the Hall effect sensor, it introduces optical switch, and one additional linear rail. And yes, your whole print head now is the touch sensor. As with any other Voron Design project, you get access to CAD, manual, information about the OptoTap, which I will touch a little bit later, STLs that you have to print depending on what type of the sensor you'll be using, configuration files or what you need to change in configuration files, and a lot of help that can be found either here or in the Discord server. But as I mentioned, you have to buy your own parts. Voron team has prepared, and on the day of the launch there were already a couple of companies that were pre-selling ready-made kits. Here comes the problem. The first release was the board that worked on 5 volts. The new design of the board, version 2.1, was supposed to work with both 5 and 24 volts. Due to some issues, unfortunately, with 24 volts. And why 24 volts? Because the original Hall effect sensor, this one here, worked on 24 volts, and people wanted simple replacement. Unfortunately, boards started burning. Actually not boards, but one of the components on the board that was supposed to regulate the voltage from 24 to 5 volts. But nevertheless, these boards are now pulled. I myself have ordered kit from Lab 4450 when this issue was not known, and in the meantime you cannot buy those boards anymore until the version 3 of the board is released that will fix this issue. If you already bought the kit and still haven't installed it, you should A. hold on to it, don't install it, and wait for the new release of the board. Or there are additional 2 options: desolder 24 volt components, or put inline resistor that should trim or lower the peak voltages when the device is turned on. Once again, I bought my board from the Lab 4450, which is true but also is not true. Actually, I bought 2 of them. One was sent as a gift, and I really do hope that the person who received it is already using it. And the second one I ordered for myself. When I buy parts from my Voron printer, if I can buy them online in the Lab 4450 shop, I buy them there. And I really do recommend them because the owner is really awesome person. But he's seen my order, he reimbursed the money, and at the end he sent me my version of the probe free of charge. So thank you once again. Currently you can buy Voron TAP kit with D2 HV switch. This is the Omron switch that replaces the optical part. This is, I wouldn't say the best method, but it still works great and even better than Kliky. So if you don't want to wait for the version 3 of the board and the final solution to this 24-volt issue, you can already order it with this switch here. But I was feeling lucky and I decided to implement this Voron kit version 2.1 on my Voron printer. As with each Voron Design project, this one also has excellent documentation, and documentation is getting better and better with each new project. There are some parts that you need to print, and those parts depend on what type of the sensor you will be using. If you will be using directly wired optical sensor, if you will be using a switch, or if you are going to use PCB. But this project, as all the other projects, has a very nice guide that will tell you on what type of the printer you need to print it, with what material, what needs to be the layer height, extrusion width, infill type, infill percentage, wall count, and solid top and bottom layers. By the way, yes, I know you can print this in a PC or carbon fiber. You can probably even print this out of resin. But documentation says ABS or ABS+. And it's not there because somebody has a deal with companies producing ABS. It is there because it's been tested. Each material also has some of the shrinkage or expansion. This, all the printing characteristics of the components you will be printing today, has been calibrated to print as it should print on the ABS type of material. If you use anything less and have issues, those are your problem. If you are ordering kit from, for example, Lab 4450, all the parts required for assembly should be there. Of course, if you bought the kit. If you bought just the switch, you have to buy all the other parts. So let's start assembling. First, you need to print a couple of parts. Front, center, right and left magnet holders, plus one of these parts here. PCB-based sensor, wired sensor, or this switch. As I said, I'm using PCB-based sensor, so I printed this part here and these parts here. Next, make sure that you have all of these parts here, plus depending on your type of the installation, parts that are listed below. My kit arrived with all the items packed in the individual bags, and of course PCB was in the anti-static separate bag. One part that we didn't mention is this MGN9 assembly tool. This is used to transfer from the rail carriage, because we will need first to install the carriage, and since the rail is short, the carriage will be in the way. If you've printed everything correctly, parts should have supports embedded in them. First step, of course, is to remove all the supports. In the next step, just add a bit of glue, and yes, glue is considered tool in the Voron Design team guidelines. Just use a drop or two of super glue, add it in the hole, press in the magnet, and that's it. Repeat this for both left and the right magnet holder. I used pliers, but you can use vice grip. Just be careful not to damage the magnets. I've seen the magnets that have split or shattered. Adding heat inserts is the next task. If you've built your own printer, then you've probably added already dozens and dozens of heat inserts. So take it slow and be careful how you add them. In the next task, we will start assembly. First, you need two M3x20 screws to bolt in the upper part. Then M3x16 to add additional support. But don't forget to leave a bit of gap. Here is where your tool head will be inserted. Depending on the type of the sensor, is it optical wired, D2HW, or optical PCB option, you now have to use one or two screws, in my case two M3x8 screws, to screw the board in. After that, we need to add M3x6 FHCS, those screws will be used to position the magnets. Just snug fit them, do not over tighten. And also on the back side add two M3x8s. Those should be snug fit, but don't fit them too tight, because the part can crack. Now we need to assemble the central part. On the left side insert the magnet with two dots on it, and on the right side insert the magnet with one dot. You also need to use for each of the magnets one M3x10 screw plus M3 washer. Don't forget the washer. How to position the magnets? Push them as far as they can go in. Then tighten them. Of course, you do not need to over tighten them, but they shouldn't move. Later on, when we finish the installation of everything on the printer, we will need to unscrew those screws so the magnets can move or wiggle a little bit the tool head so the magnets can be attracted to the screws we screwed in previously, and then once again we will tighten them. Now it's time to add the linear rail. This upper part here is used to trigger the optical sensor. We need one M3x6 bolt that goes in the first upper hole, then we need M3x8 that goes in the middle hole, and then you also need one M3x12. You need to thread in the heat set insert on it fully and then assemble it or screw it in the last bottom hole of the linear rail. In the 4 additional holes you can insert M3x6s, and those will be used to assemble everything to the linear rail on the printer. If you are using X switch or hole magnet, you need to assemble them now. There is also guide for the cables if you are using X switch, and there is a hole for the magnet installation for Hall Effect X-axis. I've also taken this opportunity to upgrade my printer. So far I have been using Fystec Dragon Voron Edition, and I will be replacing it with the E3D Revo Voron Edition. I'm not sure if this will be upgraded. If nothing else, at least it will be easier for me to replace the nozzle when and if needed. And since this hot end is considered to be official Voron hot end, I wanted to try it out. So that's why I also had to remove everything from my Stealth Burner, and that is the pre-release version or beta version of Stealth Burner, and yes, I've been using it for 1 year and it worked perfectly. And I also printed all the parts for the Stealth Burner, for the new tool head, and I had to transfer all the parts that need transferring and assemble everything. When you are at your printer, after you have removed everything from the linear rail, thread in the belts, use those 4 bolts we mentioned in the previous step to bolt everything to the linear rail. This new part has a place where you can tuck the belts, so use these to tuck in the extra belts that you have. If you need, it's also recommended that you use belt adjustment screw to release as much belt as you can, and then after you have assembled everything, use it to tighten the belt. After you have assembled this central part to the linear rail on the printer, install slowly the carriage. Next step is to install the back end where the sensor is. Don't forget the washers because you need M3x6 bolts and M3 washers. These are needed for the assembly. The Lab 4450 kit I ordered arrived with all the necessary parts, including those washers. Position on it your extruder motor with all the components and use 2 M3x8 bolts to tighten everything up. The next step is to install the toolhead itself. The toolhead should be flat on the back side, with upper part inside the bolts and the lower part sitting on the bolts down under. And of course the last part is to install the cover where all the fans are. Use original bolts from the original Stealth Burner toolhead. On the lower side I think you need to use M3x50s and the shorter screws from your existing or prior Stealth Burner on the upper holes. When you finish everything up, when everything is fitting nicely, unscrew the 2 screws that are holding the magnets on the right and the left side and just wiggle the toolhead a bit up and down. The magnets will fall into place. When they are in the place, just tighten those screws. Of course, don't over tighten, just make them impossible for magnet to move on its own. One of the steps that I had to do was also convert my Fystec Spider board to provide 5 volt instead of 24 volts. Thankfully, the board has a header pin that allows me to just remove it from 24 volt position and put it in a 5 volt position. One additional thing that I always like to do, I also double check the wiring, because I needed to crimp the connector and I wanted to make sure that the markings I did year and a half ago were correct. That the ground has been marked correctly with the black heat shrink, signal with yellow heat shrink, and yeah, I didn't have red, so I didn't mark red for the 5 volts. After I've double checked the wiring, crimped everything, it was time to play with the software. First, under stepper Z block, you need to comment out position and stop. And also under end stop pin, you need to change it from whatever pin it is currently to probe column Z underscore virtual underscore and stop, because we will be using Z virtual and stop. Also, at the end of the configuration file, there are some automatically saved settings. One of them is stepper Z, position and stop. You have to remove that part, not comment it out, because it's already commented out. If you're using save Z home, change the location to the center of the bed. I did it, and since my bed is 300 by 300, I used 150 and 150 for the position of the center of the bed. If you have homing override, make sure that it moves toolhead to the center of the bed before calling G28Z. Next step is to update your probe offset. All the values for the probe X offset and probe Y offset should be at 0. Later on, we will need to calibrate a Z offset by using the probe calibrate. Also, while we are already at the probe section, you need to add this code here. Copy it from the GitHub repository and just paste it there. What this code will do, it will check what is the temperature of the hot end. If the temperature is above 150 degrees, it will tell you that it's above the maximum allowed temperature for printer to use probe. It will then start to lower it to 150 degrees, and after it reaches the temperature, it will probe the bed. This has been added so that it prevents damaging the bed itself. Since I replaced also my hot end, which means not just the heating element but also the thermistor, it was time for me to calibrate my hot end, or to do what's called PID tuning. Documentation says that it lasts around 5 minutes, it was all done in roughly 2 or 3 minutes. And after everything has been done, it was time to test the print head. First thing, of course, is to test your Z by lifting the tool head. If you have PCB, the red LED should turn off when the tool head is lifted. Also, in the printer interface, you should see that the Z stop was triggered. After you heat soak your machine, for me this is reaching temperature of 40 degrees for some time, run the command probe accuracy samples 100. This 100 is used to break in your probe, just to verify that everything is working correctly, everything is seated. And after it finishes, you can also double check if you need to tighten a screw or two. When everything has been built, everything has been tested, you can run few more probe accuracy checks. It does 10 probe checks to see what is your accuracy. For the printers that have been built well, you can expect to see 0.0000 to 0.0008 standard deviation. Yeah, I have problem with 3 out of my 4 Z motors, actually not motors but assemblies. It looks like it moved a bit, so I have a little bit of play, and that's why my accuracy at best was 0.0010, which is still not bad. And next step, of course, for you is to print something, and I really would like to see what you have been printing. I have to be honest, I did everything, but I still haven't tuned my Z offset, and that's also the reason why I haven't printed anything yet. But I hope to do it later on today, so I can start printing tomorrow with my new nozzle or hot end. I did a lot of testing so far, and it looks like everything is working perfectly. Yes, I was a bit afraid not to A, have a problem with the board itself, B, not to connect something wrong, which as a matter of fact I did. If you see here, the two LEDs, the one for the hot end, are not working. but I think that I just damaged the connection when I was tucking in the cables, so I have to redo that part once again. I run a lot of QGLs, both on a hot and cold printer, and so far it looks awesome. So like even Miranda would say, go out and make something. And before we end the video, I really would like to thank all those wonderful people that are supporting me on the YouTube channel and that have become YouTube channel members. Thank you all for all of your support. But also thanks to each and every one of you who has watched, liked or subscribed to my channel. If you too want to support the channel, you can do so by clicking the join button down below and becoming a YouTube channel member, or going to my merchandise store and buying something there. I will be seeing you next time. Until then, bye bye, print something and have fun.